For this next problem, we know that the angle where inverse sine is positive 1/2 is in this first quadrant, and we know that's at 30 degrees. That's where we have 3/2, 1/2. So sine is 1/2 at 30 degrees. So we then know that sine of 30 degrees at 30 degrees, sine is also 1/2. So this ends up being one of those problems where you have the same value you have on the inside. So final answer is 1/2. So we hit the inverse cos button in our calculator. We make sure our mode's in radians, and we just pop this in, and we end up finding out that the angle in radians is 1.843 radians. That's the angle. Now obviously if we hit mode and we did degrees, it would look different, but there's a little more than 6 radians, which is equivalent to the full revolution 360 degrees on a unit circle. So it's okay that they look different. But if our mode's in radians, that's why we would say that the angle is 1.843 radians. If the mode was set in degrees, if we had our mode in degrees, then we would get about 106 degrees. So for inverse tan, the angle where we have this value, right, decimals, we're trying to see where we'd have that value at angle. So we're going to put in radians. If we hit that in our calculator and we put in radians, we have negative 0.0262. I'll stop there. That's in radians. If we have our mode in degrees, we would get about negative 1.5 degrees. Okay, I'm telling you right now, number 12 is going to be one of the ones people screw up. So we don't have inverse cosecant button on our calculator. So we say, what's the reciprocal of cosecant? So we know that it's sine. So we're going to use the sine inverse button. And because the reciprocals, we're going to take this number, 8.205, we'll put it over 1, and we're just going to flip it. So then we're going to put this in our calculator, mode in radians, and we get about 0.122 radians. That is the angle where cosecant is 8.205. So remember, it's not 1 over sine, it's not 1 over sine inverse. You just write the reciprocal inverse, so sine inverse, and we flip that fraction on the inside. Okay, for this next one, we're finding the angle where tan's -1, and we're looking between -90 and 90. So we know that I always think first quadrant. So I know tangent is going to be 1 at 45 degrees, but it says -1. So we know I'm going to reflect that. And so I know at negative 45 degrees, tangent is going to be 1. And then I'm finding the sine at negative 45 degrees. And then how I do that is I just say, okay, well, let me go back to quadrant 1. If it was this 45 degree line that was reflected, 45 degrees, I know that I have root 2 over 2 for cos, root 2 over 2 for sine, right? So if it's reflected, I always write root 2 over 2, root 2 over 2. So cos is going to be positive because we went to the right, and sine is negative. So if it says, what's the sine at negative 45 degrees, we know that it's negative root 2 over 2. So that's our final answer. And it makes sense because all students take calculus, so only cosine is going to be positive there, so sine should be negative. So negative root 2 over 2 is our answer. So for number 14, the first step is we say, what's the sine at pi over 2, where we can convert to degrees, 90. So the sine at 90 degrees is 1. And then we're saying, at what angle is cos 1 between 0 and 180 degrees? Well, it's positive, so I know I'm looking in the first quadrant. And let's look over here. We have 1, 0 at 0 degrees. We have 0, 1. And we have -1, 0. So cos is on the left side. So at 0 degrees, the cos is 1, because it's got to be between 0 and 180. Okay, so we first work inside. Tan of pi over 4, that angle is in radians, but in degrees it's 45. So the tangent at 45 degrees is 1. And then, again, at what angle is cos going to be 1? And we know that it is at 0 degrees because inverse cos has to be between 0 and 180. So next problem says cos pi. So we know that at pi, the cosine is -1. So now we're trying to find inverse sine -1. So we know that our answer is going to be between -90 and 90. I'm going to look over here. So I know that it's on an axis. So 0, -1, 1, 0, 0, 1. Okay, so I'm looking for where sine is -1 between -90 and 90. So sine is -1 down here, and that's at -90 degrees, or you could say -pi/2. You can't say 270 because it's got to be between -90 and +90. Okay, so for the problems where we want an exact value, and it's saying at what angle is it a certain ratio. If that ratio is not on the unit circle, or definitely if you see variables, you're going to be drawing a triangle. So I'm saying at what angle is sine 2x, 2x over 1. You can always start over 1. So I know that I'm going to draw my triangle up here in the first quadrant. So we're going to call that theta. And if sine is opposite of hypotenuse, I know that my opposite of theta is going to be 2x. My hypotenuse will be 1. So now my goal is to find this last side using Pythagorean theorem. So then we do Pythagorean theorem and we find out that that last side is 1 minus 4x squared. Sorry, the square root. So now I don't know the specific angle value, so I'm just going to call it theta because it's an angle. I have the triangle set up so that I can find the cos of that angle. So the cos, or the ratio of that angle, cos is adjacent over hypotenuse, so we know it's adjacent over hypotenuse. So the adjacent side is square root of 1 minus 4x squared over the hypotenuse of 1. So our final answer is square root of 1 minus 4x squared. Okay, so for this next problem, last problem number 18, again, we're working on the inside. So we want to know the angle. When your angle is not seen on the unit circle, for sure if you see variables, you're going to draw a triangle. So I see an x, so I'm going to put it over a 1. So I'm going to draw a triangle. I know that my triangle has to be quadrant 1 or 2. It's positive value, so I know it's in 1. Label theta. So katoa. So I know that x, it would be my adjacent. I know that 1 would be my hypotenuse. So I'm going to try to find this last side. And when I search for that last side, I get x squared plus b squared equals 1 squared. So I get b squared equals 1 minus x squared. So b is square root of 1 minus x squared. So then I know that I have theta. So ultimately you're trying to find, when you're saying inverse, you want that angle. So I don't know the exact angle, but I have a triangle set up, so I'm able to find a ratio, right? So if I'm saying what's the sine of theta, sine is opposite over hypotenuse. So given that angle that I'm referring to, the opposite of that angle is going to be square root of 1 minus x squared over hypotenuse, which is 1, so I could just leave it square root 1 minus x squared.